Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Houston, we don't have a problem. Today we're going to talk about a very fun topic, I think, and it's called elastic. Hold on. Not inelastic. Elastic collisions. So an elastic collision is a bouncy collision. And technically, the definition is that no energy is lost in the collision. So that all of the energy is transferred to the other objects. So you have an object like this, and it's traveling, and it hits another object. And then, depending on their mass and their weight, it's not very visible, is that? Depending on their mass and their velocity, then something happens. Now, the key thing to understand, different than an inelastic or a sticky collision, an elastic collision is that two things are conserved. So both momentum is conserved and kinetic energy. And we'll do some math with that. That's the key. The key is both momentum and kinetic energy. Remember, momentum is mv, kinetic energy is 1/2 mv squared. And the best way to understand how to do this, is to understand how to play this game, so to speak, is to do a problem. So if you're looking at your handout, we're going to do the problem in your handout. So we got the two curling stones problems. We've got two curling stones that are colliding on an ice rink. So stone one, so we've got a stone, boom. And stone one has a mass of 16 kilograms, an initial velocity of 1.5 meters per second. Stone two was at rest initially, and they collide dead center, giving two a final velocity. So we've got a second stone that's starting out at rest, and it gives it a velocity of 0.69 meters per second. So this starts moving at 0.69 meters per second. What is the mass of stone 2? So it's asking for the mass of stone 2. Probably should ask what's also the velocity, v1, of stone 1 after, right? v1 after. So what we've got is we've got like two sets of problems. Watch me do this. I've got momentum and I've got kinetic energy. We'll do momentum over here. So if I've got momentum, so what I'm going to do is I'm going to do m1 v1 plus m2 v2 equals m1 v1 plus m2 v2. Now, over here, we've got the before condition, and this is the after condition. Got it? So m1 is 16, right? So I'm going to say 16 times v1, which is 1.5, plus m2, that's what we don't know, right? No, but it's m1. Hold on, we do know that. Plus 16 times v1, because what's the final v1 after? We don't know that, right? Plus m2 v2. So m2, we don't know m2. So we'll say m2 times v2 is 0.69. Now what we want to do is we want to simplify this expression. So I've got my trusty calculator right here, right? So 16 times 1.5, isn't that like 24 or something? 24. So this is 24 plus 16. And actually, let's make this easier here. We're going to say v is going to be x plus 0.69, and I'm going to say y. So what can I know here? M1 equals our V1, and not M1, X. V1 equals X, and M2 equals Y. Got it? So we've got that. Now let's do the kinetic energy side. So for the kinetic energy side, what have I got? I've got a better pen. Make this I'm going to do 1/2 mv squared plus 1/2 mv squared. Oh, by the way, I didn't make a note here. I didn't do this right. Hold on. This would be equal to 16v, right? That's what it is. So this is going to be an equal sign right here. Why is this an equal sign? Because I didn't do the M2V2 because the stone M2 had a 0 velocity. So if I say M2V2, it would be times 0. Okay. All right. Sorry, I am confusing you probably a little bit. And that is equal to 1/2 mv squared plus 1/2 mv squared. And we're going to, this is the before condition, and this is the after, right? Finally, this is the pen that's going to work. So this will be 1/2 times 16 times, now let's use our thing. This is going to be x, so this is going to be x squared. And then plus 0, because this velocity is 0, right? Is equal to 1/2 times 16 times x squared. Actually, this is not x squared. This is 1.5 squared. Plus 1/2 times the mass. We don't know the mass, so we're going to call that y times 0.69 squared. Got it? All right, now what I want to do is simplify all these. So 8 times 1.5 is, no, it's 1.5 squared. So 0.5 times 16 times 1.5 squared gives me 18. So that's 18 plus 0 equals, so 18 equals, that's half of 16, that'd be 8x squared plus, all right, and I got 0.69 squared, 0.69 squared times 0.5, or divide by 2, right? And this gives 0.238 y squared. Now here's the deal. I've got two equations. I've got this equation right here. I've got this equation here, and I've got to solve for x and y. Now to solve for x and y, you want to use Desmos. So let's flick to Desmos and plug in these equations. All right, I've got Desmos up, and looking at the numbers, I'm simply going to type in these equations, right? So I'm going to say 24 equals, not plus, backspace, equals 16x plus 0.69y. Draws a graph. You see the graph over here, the red line. Now I'm going to type in the second equation, right? I'm going to say 18 equals 8x. Now you have to use like the shift caret button, caret 2 for squared, right? And then plus 0.238 y. It's a shift of the 6 button. And there we go. Now what you'll notice here is in this graph is that we have kind of an oval shape and then we have a straight line. And what I want to do is I want to find the intersection points. If I highlight this, I'm going to write these on the board here. You can't see it. 1.32, comma 4.093. And then if I zoom in at the other intersection point, which is going to be down here somewhere, 1.5, comma 0. All right, so now here are our numbers, right? So remember V1, x was V1, and this is M2, and this is V1 and M2. Now this is an obvious answer. Which of these two makes sense, right? The mass of the other object can't be 0, right? So it turns out that when you're doing these problems, what you have to do is you have to look at the numbers. Only one of these sets of numbers is going to make sense. Clearly, 0 mass doesn't make any sense at all. So the answer has to be this and this, 1.32 and 4.093. So 1.32 is the velocity the final velocity of this one. By the way, the fact that it's 1.32 means it's going to keep moving off to the right. If it was negative, it would bounce back. That does happen sometimes. And then the mass of this object is 4.0 kilograms. So a 16 kilogram hits a 4 kilogram. He gets accelerated at 0.69, and some of that energy keeps going. This slows down. It was at 1.5. It's dropped to 1.32, and that's how you do these. So it's a combination. Is you're going to get this here, you're going to get this here. You're going to have two equations. You're going to solve for them. By the way, most of the questions in the test or on the in the packet, I'm to say, is you're going to have solving for V1 and V2. So you're going to have, you'll know this is 16 kilograms and this is 10 kilograms or something like that. You know this speed. You might even know this speed, and it might also have a negative speed. It may be coming in the opposite direction. It could happen. And then you're going to solve for V1 and V2. And I usually solve this, I call this X and this Y, or whatever, the V's. You're usually solving for the V's and not the M's, but you can solve for the M's too. It's the same idea. So that's how you do the equations. Use Mr. Desmos. He will be your friend in a big way as you're solving these problems. Houston, we don't have a problem.